Hi guys, in this video I'm going to describe about some problems from Charles Alexander 5th edition, and these are from the 10th chapter, and the problems that I have got in this video are from the exercise problems. That is, I have taken a certain batch of problems that are 10.6 to 10.10. Okay, moving on to the first problem, that is, let us see the question, and it is 10.6. We have to determine is the potential across this 20 ohm resistor, where we have a current source of about magnitude 3 amperes and a phase angle of 0 degrees, and we also have a voltage dependent current dependent voltage source, which has a magnitude about 4 Vx, and 20 ohm resistance over here, and inductor over here which has a inductive impedance of about J10 ohms. Over here, as we can see, we have a current dependent voltage source, which depends upon the voltage Vx. As we can see, the Vx is the potential drop across the 20 ohm resistor, and what this source does is that it just amplifies 4 times the potential drop across this resistor, and it just creates a new voltage source. So moving on to the solution part, we have just declared an assumption, and we are using nodal analysis in this part right now. So we have considering this node, where we assume it as V naught, as we can see in this video, V naught minus 4 Vx. V naught minus 4 Vx, that is V naught over here node, over this node, minus 4 Vx, that is the potential drop across this part, by 20, that is the resistor over here, which gives a current over this part, and minus 3, which is a current over this part, and V naught by 20 plus J10, that is, we have V naught over here, and 20 plus J10, that is, sorry, that is resistance over this part, that is J10 plus 20 ohms. And we are also assuming that there is a ground connection over here which has a potential of 0 ohms. So to say, we are assuming that this place has a potential of V0, and this place has a potential of 0. So we finally get an equation by nodal analysis that V naught minus 4 Vx by 20 minus 3 plus V naught by 20 plus J10 equals 0. And further solving this, we get Vx equals 20 V naught by 20 plus J10. And also, when we combine both these equations, that is Vx equals 20 V naught by 20 plus J10, which is obtained by just considering this branch alone, we are using Kirchhoff's voltage law right here. So we are obtaining this equation right here, and combining these two equations, we are just getting a linear equation, and V naught. uh, Further solving this equation, we just get this linear equation, and we are getting it as V naught equals 60 plus J30 by minus 2 plus J into 0.5, which gives us a value of Vx equals 20 into 3 divided by minus 2 plus J into 0.5, which gives us a magnitude of 29.11 volts and a phase angle of minus 66 degrees. So this is the final answer that we have obtained, and yeah guys, that's it. Moving on to the next question, that is in Problem 7, that is 10.7. We have to, the question says that we have to use nodal analysis to find V in the circuit. That is, V is potential in this node right here. These all 3 points together are considered as a node. So, considering this situation, we have a potential voltage source across here which has a magnitude of 120 volts and a phase angle of minus 15 degrees, connected in series with a 40 ohm resistor and an inductor having a inductive impedance of J20 ohms. There is also a current source which has a magnitude of about 6 amperes and it has a phase angle of about 30 degrees, and it's connected in parallel with capacitor having a capacitive impedance of about minus J30 ohms. And also there is a resistor 50 ohms which is also connected in parallel. And we have as usual ground connection which indicates us that this is zero potential point. So we have a situation where this is the point where we have or a node where we have potential as V, and this is a point node where we have the potential as 0. So moving on to further solutions, so which we use by which we get by nodal analysis as assuming this branch, we get as 20 and the space angle minus B, as we can see here, divided by the total resistance, that is 40 plus J into 20 ohms, as we can see here, equals the current flowing through this branch, that is 6 and 30 degrees phase angle, plus B minus 0 by this total uh, resistances. So it gives us this equation, primary equation in B alone, or to say Bx, as we have seen, or V, and this gives us this secondary equation, which on solving gives us V equals minus 3.1885 minus J 4.7805 divided by 0.04 plus J into 0.0233. Which on simplification gives us 124.08 and a phase angle of minus 154 degrees, and guys, don't forget the unit, it's volts. Okay guys, moving on to the next problem, that is 10.8, where we use nodal analysis to find the current I naught in the circuit. So the current I naught is present over here with we are assuming a potential drop across here as V naught, and as we can see, we have a current source over here, a resistance over here, capacitor over here, inductor over here, and these are nodes where the potential across this node is just V1, and in this node it's V2, and there is a what to say current dependent voltage source, and now I also forgot to mention that here's a resistor of about 40 ohms. Okay, moving on to the solution, where we get the omega has 200 from the question, and impedances, that is the inductive impedance and the capacitive impedance. The inductive impedance is given by J omega L, which is equal to J into 20, and the capacitive impedance, which is equal to 1 by J omega C, which is given by minus J into 100. So coming back to this point where we consider the node 1, we are considering the voltage source along with the the source, that is the dependent source, where 0.1 V naught is the voltage, and considering the other part where V1 by 20 comes into play, that is a V1 is this node where it is common to all these branches. So V1 by 20, and this point is assumed to be, this whole entire thing is assumed to be zero potential, as we have seen in this last question where it is a ground point. So we are just assuming that this point has a potential about 0 volts, and this entire line has a potential about V1 volts, and this entire line has a potential of about V2 ohms. So we get a potential difference about V1 minus 0, and we are also considering the resistance over here. So we are getting V1 by 20 plus V1 by minus J100, that is over here, and we are also considering the difference between these two by the resistance over here, which gives us V1 minus V2 by 40. Further solving this equation gives us this first equation, primary equation. Then back to the circuit, we also have a new node over here, that is V2, which has a potential V2, and we can also solve it as V1 minus V2 by 40, or the potential difference across these two nodes by the resistance across it equals 0.1 V1 plus V2 by J20. That is the potential across this source, that is the voltage source, and the 0, that is the ground point over here, and the V2 over here. So the V2 minus 0 by J20, that is the resistance over here. So it is given as V2 by J20. So we have 0.1 V1 plus V2 by J20. On simplification, we get 0 equals 3 V1 plus 1 minus J2 V2. This is the second equation. As we can say that these two are simultaneous equations. On solving, we get two values, that is V1 and V2 individually. So we get V1 as minus 70.63 minus J into 127.23 volts, and V2 as minus 110.3 plus J into 161.09 volts. So we can just substitute these values and find out I naught, that is I naught equals V1 minus V2 by 40, that is I naught is the current flowing over here, and by applying Ohm's law, that is the potential difference across these by the resistance in this branch, gives us a current flowing through the branch. So V2 minus V1 or V1 minus V2, whichever is, gives us a positive result by 40, that is resistance value gives us, that is V1 minus V2 by 40 equals 7.276, and a phase angle of minus 82.17 degrees. And don't forget the unit, guys, and it's an ampere. Okay guys, the problem's over. So going on to the next problem, that is 10.9. It also says that we have to use nodal analysis to find V0 in the circuit. So seeing the circuit, we can say that we have a potential source with a phase angle of 0 and a magnitude of 10 volts, and there are about two resistors of 20 ohms each, and a capacitor having a minus J20 impedance, and there is a current source, that is a what is it, current dependent voltage source, that is 4 I naught, and there is inductor with the inductive capacitor, the inductive impedance of about J10 ohms, and there is finally a resistor with 30 ohms. So the question says that we need to find V0, which is over here, and this is I naught, the current flowing through this branch, and this dependent source depends on the sinus, so it amplifies 4 times I naught in this branch. There are also two nodes where we have V1 over here and V2 over here, and this entire line in the bottom is considered to be a ground connection, so we can assume it as a zero potential point. So considering the solution, we have 10 cos 10 about 3t equals 10 into the phase angle, that is 0 degrees, as we can see in this circuit. And we can get omega as 1000 from this equation, and both the impedances, that is ZL and ZC, that is inductive impedance and the capacitive impedance. The inductive impedance is given by j omega L, which is J10, and the capacitive impedance is given by 1 by j omega C, which is equal to minus J20. Also, in this case, since we are applying nodal analysis, we have to consider both the nodes, that is V1 and V2. So, considering V1, we can say that we have to consider this branch, and this branch. So, considering this branch, we have 10 minus V1 by 20, that is this one by which is equal to the current flowing over here, which is V1 minus 0, since this is a 0 potential point. So V1 minus 0 by the resistance over here, which is 20, which is here, and V1 minus V2, that is a potential difference over here, by minus J20, as we can see over here. So, simplifying this equation, we get it as 10 equals 2 plus j v1 minus j v2. And keeping this equation aside, as a primary equation, we move on to another node which is present over here, that is the second node, which has a potential of v2. And considering the potential over here, the node over here, we have to apply nodal analysis, and it gives us v1 minus v2 by minus j20, that is what is over here, equals the current flowing over here, which gives us 4 I naught, which is not considered as a case since it's been substituted, and it is given as v1 by 5 plus v2 by 30, that is v2 minus 0 by j10 plus 30, which is given over here, v2 minus 0, which is not considered, by j10 plus 30. So we get a second equation, and on solving that, we get a second primary equation, which gives us v1 equals 0.6 plus j into 0.8, v2 by minus 4 plus j. Since we have two equations in two variables, we can solve these two to get the values of v1 and v2. And since we need only v2 in the case of v0, we just get v2 as 170 by 0.6 minus j into 26.2. So substituting this value in the case of this one, since we are applying nodal analysis, we can also say that V2 minus 0 by this total resistance gives us the current flowing over it, and we can also say that according to Ohm's law, the current flowing over this branch into 30 gives us a potential drop across this resistor. So we are saying that 30 into current flowing over this branch, which is given by V2 by 30 plus J into 10, we get the potential drop across the resistor, which is equal to 6.154, and it's at an angle of 70 plus 26 degrees in phase. Don't forget the unit as usual, and converting it in the cosine form, we get it as 6.154 cosine of 1000 t plus 70.26 degrees volts. Now guys, the 9th question is over, and finally the 10th one. And the 10th one, it's a problem 10.10, and as usual it says that we have to apply nodal analysis to find V0 in the circuit. Since due to error, I have just missed the V0 over here, and as we can see in the question, we have 36 ohms, actually 36 amperes over here, and at an angle of 0 degrees in phase, and we have having a 2k ohm resistor in parallel with it, along with the inductor in parallel, which has about J100 inductive impedance, and we're also having a capacitor with capacitive impedance of about minus J250, and there is a independent source, dependent source, which is about 0.1 V1, where V1 is the voltage in this node around here. So we can say that V1 is the potential across this entire node, and V2 is the potential difference across this entire node. And this is a resistor connected in parallel across the circuit, and there is a resistor which I missed out by mistake, and it has a potential drop of, which is about V naught. So going to the solution part, we get the inductive impedance, which is about J omega, and we get it as J100 as specified in the figure, and omega is 2000 as shown in the figure, and capacitive impedance is about 1 by J omega C, which is about minus 250, which is also shown in the figure. And considering the nodes right now, we get at node 1, which is this node, we get as 36 minus V1 by what to say, nothing, that is 36 equals V1 divided by 2000, that is 36 equals V1 divided by 2000, that is 2k, plus V1 divided by J100, that is V1 divided by J100 over here. And also I forgot to mention, we are assuming this line as usual to be a zero potential area or line. So V1 by J100 plus, and as usual the potential difference across this branch, which gives us V1 minus V2 by the potential resistance across this branch, which is about minus J250. So this is minus J250 over here. So solving this, we get a primary equation which we will be keeping aside to be solving a simultaneous equation in this problem. So considering the next node, which is over here, we can see that it extends over this area, and we are having a dependent source over here. So we can say that V1 minus V2, that is this line, by minus J250, as you can see here, equals 0.1 V1 plus V2 into 4 kilo ohms. So the V naught is percent over here, so we can't, it's not entirely over here. So solving this equation gives us a second primary equation, and solving these two equations 1 and 2, we can get the value of V2 as minus 535.6 plus J into 893.5, which in turn gives us 8951.1, and a phase angle of 93.53 degrees. And as usual, don't forget the unit. And as a function of time, it is expressed as 8.951 sine of 2000 t plus 93.53 degrees, and that the unit is changed as kilovolts, since this expression is divided by 1000, that is 8.951 into 10 power 3, and the 10 power 3 is taken as kV. So that's it guys, thanks for watching this video, and please hit the like button if it's good. Thanks.